Welcome back to our deep dive series on the Online Encyclopedia of Integer Sequences, the OEIS.
Hello. Yes, the OEIS.
If you've been following along, you already know it's just, well, an amazing resource,
I-
especially, I think, for anyone getting into number theory.
Oh, absolutely. It's more than just a list. It's really a gateway.
Yeah, like a map, right? You look up one sequence, one string of numbers.
And suddenly you find all these connections, these paths you didn't expect.
Exactly. It can turn, a real puzzle into something understandable, a starting point.
A crucial first step, often. It gives you context, formulas, papers to read. It can really kickstart the understanding process.
So today, we're going to zoom in on one specific entry. It's A000192.
Ah, yes.
And the title is intriguing. Generalized Euler Numbers.
Mm-hmm. That title does immediately catch the eye.
Right, because many listeners probably have bumped into the standard Euler numbers somewhere.
Sure. They appear in, well, various places. Series expansions, combinatorics.
Even things like special values of the Riemann zeta function, right?
Yeah. Indeed. So the term generalized naturally makes you think, well, what's being generalized here?
What does that mean in this context?
Precisely. In math, generalized usually signals that we're taking a core idea and stretching it, broadening its scope.
Making it apply to more situations.
Exactly. So this sequence, A000192, it suggests a link to Euler's work, obviously, given the name.
Either something he maybe worked on himself, or perhaps something inspired by his approach, that generalizing spirit he had.
It could be either. Given Euler's, well, immense output, it's plausible he touched on it, but it might also be a later development building on his ideas.
Okay, so that's kind of our goal here, to unpack what generalized Euler numbers might actually point towards.
Right. Not just list the numbers, but understand the label.
Does the OEIS entry itself tell us it's significant? I mean, it has its own number.
Oh, definitely. Having an entry signifies it's a recognized sequence, something mathematicians have studied or found useful.
And thinking about Euler, his work often laid the groundwork for bigger theories, didn't it?
It absolutely did. Think about partitions, generating functions. He started exploring those, and entire fields grew out of it.
Or even graph theory, starting from that Königsberg bridge problem.
That's a classic example. His initial insights often opened doors, even things that weren't maybe his main focus, like Catalan numbers.
Right, I read that those showed up more in his letters, his correspondence, not huge published works necessarily.
Yes, which just shows how wide-ranging his thoughts were. His way of working was also key.
You mean how he wasn't afraid to just calculate?
You know,
Generate examples?
Exactly that. He'd make tables, look for patterns, really get his hands dirty with the numbers. His work on multinomial coefficients is a good example.
He calculated terms, looked for relationships. Didn't he even include a mistake once, like a flawed induction deliberately?
As a teaching moment, yes. It shows that deep engagement with finding the structure, combining exploration with, eventually, rigor.
That feels very Euler. Intuition, experiment, then proof.
A powerful combination. And makes you think, maybe 800192 came out of a similar process.
Either by him or someone following that path, extending the properties of the standard Euler numbers.
It fits the pattern of mathematical evolution, doesn't it? You find something interesting, and the next question is often, can we generalize this?
Does it work if we change this condition or add this parameter?
Right. And the OEIS, in a way, captures many of those explorations. These sequences often represent those generalized concepts.
So for a student finding A00000192, that label, generalized Euler numbers, is really a signpost.
It absolutely is. It tells you, okay, first understand the original Euler numbers.
Their definitions where they show up.
Yes. And then the interesting part is figuring out what got generalized. Is it the generating function, the combinatorial meaning, or recurrence relation?
That leads us back to using the OEIS effectively, right? Don't just look at the list of numbers.
Crucial point. You have to look at the comments, the formulas provided, the references, the keywords.
That's where the clues are hidden?
That's where the context lies. It tells you the specifics of this generalization.
The OEIS isn't static. It's like this web of ideas.
A network. Exactly.
And the name, A000192's name, is one of the first threads in that web, pointing towards Euler and generalization. Like you said, a breadcrumb trail.
And given how many areas Euler worked in, number theory, series, mechanics, optics, you name it, the potential scope of generalized Euler numbers could be quite broad.
It could touch on any number of those fields, potentially.
It's possible the connections in math can be surprising.
Okay, so wrapping up this part of our deep dive, focusing on the name. The key takeaway seems to be that A000192, these generalized Euler numbers, are almost certainly tied to Euler's legacy.
Yes, either directly stemming from his work or inspired by his foundational concepts and his method of extending ideas.
The name itself signals broader themes, extensions of the familiar Euler numbers.
It's a clue, more than just a label. It guides your exploration towards how fundamental ideas grow and connect.
So as you, the listener, explore the OEIS and maybe come across A000192, remember that name carries weight. It hints at a deeper story, which leads to maybe a final thought to leave everyone with.
Okay.
Considering Euler's vast shadow and, well, the sheer size of the OEIS, how many other sequences in there, maybe with less obvious names, also have these deep connections back to fundamental ideas or major figures?
That's a fascinating question. There are likely countless hidden connections waiting to be traced.
So maybe take this dive into A000192 as a bit of inspiration. Keep exploring the OEIS, follow those numbers, see where they lead.
You might uncover some really surprising mathematical territory.
Absolutely. Thanks for joining us on the Deep Dive.